Today we're going to talk about a second way to solve quadratic equations. Yesterday we talked about completing the square. Another way to solve a quadratic is to use the quadratic formula. The quadratic formula, you might have seen this before. I know a lot of my students have when I teach this every year. But if you have an equation that has an x squared in it, and there's an ax squared plus bx plus c equals 0, and the only thing is that a can't be equal to 0. So if you have some kind of a quadratic equation, if it's set equal to 0, you can always find the two roots of a quadratic equation by using this formula. In this formula, you'll find two values of x, because quadratic equations have two roots or two solutions. And here's the formula in here, and if you know the song Pop Goes the Weasel, or maybe your algebra teacher or geometry teacher taught you this song, you sing along to the tune of Pop Goes the Weasel, and I'm sure you'll get a kick out of this because I can't sing very well, but it goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right, so you can laugh your head off at that song, but that helps everybody. It usually helps people remember how to solve a quadratic equation that's been set equal to 0. So what you need to do, there's only 3 steps to solve a quadratic equation. First of all, make sure it's in standard form by getting the x squared, then the x, and then the plain old number equal to 0, and write down what the values of a, b, and c are. A is the number in front of the x squared, b is the number in front of the x, and c is the number that doesn't have an x in front of it. And then you substitute those 3 values into that formula and then simplify if possible. So this first example, we're going to solve it using a quadratic formula and then simplify the answer. The two values are called the roots. Just like yesterday on the previous page, we talked about the two x values. The two solutions to quadratic equations are called the roots. Okay, this first one, the first thing we have to do is get it into standard form. So we write it as ax squared plus bx. Well, we have to subtract 9x from each side because we've got to get a 0 over here. So it's x squared minus 9x plus 8 equals 0. So off to the side, I would like you to write down what a, b, and c are. A is the number in front of the x squared, which is an invisible 1. B is the number in front of the x, which is a negative 9. C is the number that stands alone, which is just an 8. And so we substitute those 3 values into x equals negative b. Well, a negative 9 is a positive 9, plus or minus square root b squared. Well, I always just square b in my head. Negative 9 squared is positive 81. B squared minus 4ac all over 2a. 2 times 1 is 2. All right, it's a good idea just to square b in your head and write it down because the b squared value is always positive. Some people make the mistake in saying negative 9 squared is negative 81. But don't do that because a squared value is always positive. So we simplify what's underneath. 9 plus or minus. There are 2 answers. There's 9 plus this and 9 minus this. Now 81 minus 32. Well, I guess I'll just get my old calculator out here and do 81 minus 32. And that's a 49. All over 2a. All right, the square root of 49 is just 7. So I'm going to simplify that radical down. Plus or minus the square root of 49, which is just 7. Not square root of 7, but just a 7, all over 2. Now you have 2 answers here. 9 plus 7 over 2. 9 minus 7 over 2. So we have x equals 9 plus 7 over 2, which is equal to 9 and 7 is 16. 16 over 2 is 8. And x is always also equal to 9 minus 7 over 2. 9 minus 7 is 2, and 2 over 2 is 1. So those are the two solutions, x equals 8 and x equals 1. And good thing for these kind of equations, you won't get an extraneous solution here. Over here, we have to subtract 8x from each side, so we have 3x squared, subtract the 8x, and add the 2, so we can get a 0 on that side of the equation. The next thing we're going to do is mark down what A, B, and C are. Here we go. In this case, A is equal to 3, B is equal to -8, and C is equal to 2. And then we substitute x equals -b plus or minus the square root. 8 squared is 64. B squared minus 4ac all over 2a, which is 6. Simplify that radical down. 8 plus or minus the square root of 64 minus 4 times 3 is 12, and 12 is 24. 64 minus 24, I believe, is 40, all over 6. Now 40 has a perfect square. I'm going to break 40 up into 4 times 10, and this 4 you can take the square root of and it comes outside, so that's going to become 2 square root of 10. So we have 8 plus or minus 2 square root of 10 all over 6. And then when you simplify this down, there are a couple of ways to simplify it, but my suggested way is that you circle both of these so you're not by mistake just canceling out a term, because you have to actually, you can make this into two different fractions. X is equal to 8 over 6 plus or minus 2 square root of 10 over 6. You can do it that way. And then 8 over 6 reduces down to 4/3. And the 2 over 6 reduces down to 1 over 3. So this becomes the square root of 10 over 3. Or if you wanted to put it back together again, you can call this 4 plus or minus the square root of 10 all over 3. And that's the end of that. Number 3, this is already written in standard form. So A is 2, B is -4, whoops, and C is 5. And X equals -b plus or minus the square root of 4 squared is 16 minus 4ac all over 2a. Okay. 16 minus 4 times 2 is 8. 8 times 5 is 40. This is a negative value. Let's see. 16 minus 40 is equal to -24 all over 4. All right, when you have a negative underneath the radical, we're just going to call this for now. This is not a real solution because you can't have a negative underneath the radical yet. We're going to talk about that in a little while, but we're just not going to call that anything right now. We're just going to stop right there when we have a negative that goes underneath that radical. All right, and then the last one, I'm going to add 9 to both sides. X squared minus 6x plus 9 equals 0. A is equal to 1. B is equal to -6. C is equal to +9. And X equals -b plus or minus the square root of b squared is 36. Minus 4 times a times c all over 2a. And we can simplify this down. 4 times 1 times 9 is 36. So x equals 6 plus or minus the square root of 36 minus 36 is 0 all over 2. Well, the square root of 0 is 0, so what we have is 6 plus the square root of 0 over 2, and we have 6 minus the square root of 0, which is 0 over 2. Well, 6 plus 0 is just 6, and 6 over 2 is 3. 6 minus 0 is 6, and 6 over 2 is still 3. So you really have two roots that are equal to each other, but we'll just call it x equals 3 in that. And that's about it for today. That was about it for today on this page 2. I think I'm going to go on to page 3 and just talk about a little bit about a very important part of the quadratic formula, which is called the discriminant. This is your new vocabulary word for the day, discriminant. And the discriminant tells what kind of roots you have to a quadratic equation. Now, if you have a quadratic equation that's written in standard form, if you remember b squared minus 4ac, that part of the quadratic formula, that's the part underneath the radical. Right? If you remember that that's underneath the radical, that b squared minus 4ac, that's called the discriminant. And when you have, if you remember, when you have a quadratic equation, when you solve it for x, any way you solve it, the values of x are called the roots, or the solutions. And the discriminant, that b squared minus 4ac, that part of the formula, the discriminant tells the nature of the roots or what type of roots. It doesn't tell what the roots actually are, because if you want to know what the roots actually are, you're going to use the entire formula. But if you want to know what type of roots you have, you can just look at b squared minus 4ac's value. Okay, so what we're going to do is we're going to look at these 4 examples down here, and we're going to figure out whether the roots of these equations, the roots are going to be, once they simplify this down, we're going to say about the two values, are these values real or are they imaginary? If you remember in the previous page, we had one example that had not real solutions. If it's not a real solution, it's called imaginary. And we'll talk about that in another day or two. Okay, are the two x values rational or are they irrational? And are they equal or are they unequal? Okay, that's the type of roots. So when we have x equals 3 plus the square root of 25 over 2 and 3 minus the square root of 25 over 2, we're going to figure out whether they're real or not, whether they're rational or not, or whether they're equal or not. All right, so sometimes I do this when you have a quadratic, this is the quadratic formula all worked out, and we have two values. One is 3 plus the square root of 25 over 2, and the other one is 3 minus the square root of 25 over 2. We have two values coming out of there. Well, the square root of 25 is just 5. So 3 plus 5 is 8. And 8 over 2 is just 4. 3 minus 5 is negative 2. And negative 2 over 2 is just negative 1. So are these two values real or not? These are real for number 1. These are real numbers. Are they rational numbers? Yes, rational numbers are numbers that don't have radicals, a radical that is not a perfect square. So these are rational. And are they equal? No, 4 is not equal to negative 1, so they are unequal. So that's the type. This is the type of roots that this question number 1 would have. These x values are this type. Now in number 2, we have 3 plus the square root of 27 and minus the square root of 27. But what I'm going to do is I'm just going to take this 27 down, and I'm going to simplify that because 27 is 9 times 3. So this turns out to be 3 square root of 3 if you simplify it, all over 2. Well, are these real numbers? Well, yes, they're real numbers unless you have a negative underneath the radical symbol. So these are real numbers. They're not imaginary. Are these rational? Well, they're not rational because this square root of 3, this is an irrational number. It's not like the square root of 25 where we just took the square root of 25 and got a 5 out of it, no more radical. This is an irrational because the square root of 3 is not rational. So this is irrational. This is the irrational part of this question. And then, of course, these two numbers, 3 plus the square root of 3, or 3 plus 3 square root of 3 over 2 is not equal to 3 minus. So they are unequal. So these are the type of roots that question number 2 would have: real, irrational, and unequal. Down here on number 3, if you remember from the previous page's example, we have 3 plus 0 over 2, and we have 3 minus 0 over 2. Well, this just becomes 3 over 2, and this becomes 3 over 2. They're the same thing. They're equal to each other if you have a square root of 0. So are these roots real? Yes, they're real numbers. Are they rational? Yes, because they don't have that square root that you can't simplify. They are rational. And are they equal to each other? Yes. So this is the type of root that, these are the type of roots that question number 3 has. That's the type. They are real, they are rational, and they are equal. Now over here on number 4, if you see a negative underneath that square root sign, it's not real. It's not a real number. Negative under square root means not real. Okay, so this whole thing is these x values are not real numbers, they're imaginary. So we're just going to call it imaginary, and then we're going to stop right there. We don't have to classify it with the green and blue type up here. It's just imaginary. So that's the type of roots. They are imaginary because of this negative, because you can't do the square root of a negative number. At least we don't know how yet. And that's the end of the day today. Talk to you tomorrow.